Applications involving a radical equation. The first application is going to involve finding a number. So our unknown will be x, which will represent the number. Now, to write the equation, we're going to have to look at the expressions in this problem. Most importantly is 5 less than a number. And how is that written? That is written x minus 5 because less than is the same as subtracted from. Then we're going to have to take that expression x minus 5 and then take the square root of it. So the equation will be the square root of x minus 5 is or equal to 4. Now to undo a square root, we need to square it. And when you square a square root, you end up with the expression underneath the radical. And then 4 squared is 16. Add 5 to both sides of the equation. X equals 21. Now whenever you are squaring in a square root equation, you need to check your answer. So substituting 21 into the original equation, we have the square root of 21 minus 5 equals 4. Square root of 16 equals 4. Yes, that checks. So in this application, we would say the number is 21. A second application we're going to look at is the rate at which firefighters spray water when working to put out a fire is F equals 120 times the square root of P. F is the water flow in gallons per minute. P is the nozzle pressure in pounds per square inch. What nozzle pressure is needed to achieve a water flow rate of 600 gallons per minute? All right, we're looking for nozzle pressure. That is our P. So nozzle pressure, that's the P. All right. We're being given the flow rate of 600 gallons per minute. That is our F. So we're going to substitute 600 in for F and then solve for P. So we'll have 600 equals 120 times the square root of P. Divide both sides of the equation by 120. 600 divided by 120 is 5. 5 equals the square root of P. Now again, to undo that square root, we're going to square both sides of the equation, and we end up with 25 equals P. So what is that P? The P is the nozzle pressure, so we will say the nozzle pressure should be 25 pounds per square inch.